Hi students, now in this class we are going to discuss little bit different questions when the friction is involved, how to solve. Okay, uniform beam of mass m is inclined at an angle theta to horizontal. Its upper end produces 90 degrees bend in a very rough rope tied to wall, and its lower end rests on the rough floor. Coefficient of static friction between the beam and the floor is μs. Determine the expression for maximum mass m that can be suspended. Maximum mass that can be suspended from the top before the beam slips. So before starting the question, better to read it twice and thrice, but I'm starting now. But when you're going to start, pause the video and read it for 2 times and then start solving. If you consider it free body diagram, the downward force, there is a downward force capital mg, and there is a friction. We don't know which direction the friction is acting. Let's do free body diagram and then we can decide the mg, small mg it is acting, and here is a tension T, and yeah, the friction will be okay. Now the downward force, next we can balance. If it is in equilibrium, net force is equal to 0 and net torque is also equal to 0. Because the friction is involved, there is a normal force here, and let's consider about point here, and let's consider about point P. All the points should be, net torque should be equal to 0. Net torque should be equal to 0. Net torque is equal to 0. And if you consider overall system, net force I am calculating, net force, net downward force. Tension is internal force, it gets cancelled. Here also it gets cancelled. And net downward force is equal to how much? Capital M plus small m into G is equal to, and upward force is minus, it is equal to normal, right? This downward force is equal to net upward force. The tension gets cancelled and everything. Here also at P there will be normal reactive force, it gets cancelled, because upward on the rope it is in the upward direction, on the rod it is in the downward direction. Both the sides it gets cancelled. Okay, tension is in a horizontal direction and its internal force, tension on the both sides gets cancelled. Okay, normal we got. Let's do from net force is equal to 0, we got these expressions. Net torque is equal to 0. About which point we apply, that actually matters a lot. If we apply at, we can have many number of points, 1, 2, 3, any number of 3 points are there. About which point if we apply, it will be easy. We don't know tension. We better to remove the parts if you don't know. That, see, if we consider point P and the tension is passing through the point P, because the torque due to tension becomes 0. Understand, right? Whatever you don't know the values, better to consider the point of rotation as that point. I don't know tension T, I am considering the point P as the axis of rotation. Because of tension, the point torque is equal to 0. It becomes easy for me. Torque T will be eliminated. So next, let's do torque balance for this rod, and the angle given is theta, and in the downward direction the force is mg, and this is small mg, the tension normal, friction I am considering, okay, let me consider in this direction. You will understand how to consider the direction from this diagram. Now see, about the point P I am doing torque balance. Torque due to T and torque due to mg becomes 0. Okay, torque due to normal is equal to small m plus capital M into G. Okay, let's see about mg. Mg about point O, the distance is here, and you are pulling the rope and it goes in this direction. What kind of direction? Clockwise direction. So plus mg, how much is the distance? L by 2. There is an angle theta. Perpendicular distance how much? Mg L by 2 cos theta. So this is the axis of rotation, right? Don't say sir mg L by 2 only directly. This is the axis of rotation. From here to here the distance is L by 2 cos theta plus mg L by 2 cos theta, clockwise direction. And due to normal in the upward direction, the point P is here. Because of normal it is in this direction. What kind of direction? It is clockwise or anti-clockwise? Anti-clockwise. It is equal to minus n. N is nothing but n is equal to capital M plus small m into g. What is the perpendicular force to here? The distance is L by 2 cos theta, and due to friction it's in the backward direction. The friction, due to friction, and the friction about this point. Say I am writing friction here. Force is a vector, I can write anywhere f, and here is L by 2 sin theta. So if we consider, this is which direction? It is in the opposite direction, minus f into L by 2 sin theta. F is nothing but mu s into n. Okay, mu s into n, right? Mu s into n. If we simplify it, mg into L by 2 cos theta minus capital M plus small m into g into L by 2 cos theta minus f is equal to mu s into n is equal to capital M plus small m into g into L by 2 sin theta. Net torque is equal to 0. From here what we are supposed to get? We are supposed to get capital M. Net torque is equal to 0. This is the value we are going to get, right? What he asked? So he is asking maximum mass. So maximum mass, if the maximum mass is asked, listen carefully how to solve it. Maximum mass is asked. Now mg L by 2 cos theta is acting in which direction? Downward direction. And the remaining other forces acting in direction? Opposite direction. So what you consider is correct, because all this one fellow try to balance all other forces. Okay, you can consider in that way. You try to solve it, you will get an expression for capital M and small m. Get the relation for m. And the reactive force is from the floor. R is equal to two forces are acting. How this is action? Perpendicular to it, square root of f square plus n square, friction square plus normal square. Okay, one side you consider minus fl by 2. In another case consider plus f into L by 2 sin theta. Solve for these two cases. This one case minus consideration of minus, and another case you consider the plus f into L by 2 sin theta. Out of these two cases, whatever you get maximum, that will be the maximum mass of m. That can be hanged. Other questions are there, you can try other questions. This is the tough. See here, a ladder as shown in the figure has negligible mass at rest on frictionless floor, crossbar connected two legs and a ladder at the middle. The angle between the two legs is 60. So draw the free body diagram. He is asking, fat person is sitting and has a mass 80 kg. Find the contact forces by the floor. Floor is normal reactions. Contact forces are normal reactions, N1, N2 and N1. The downward force is how much? 800. How much is an angle? 30 degrees, because 60 degrees is given, bisector it is, and it is 30. Okay, N1 first upward force, N1 plus N2 is equal to 800, because net force is equal to 0. Next, torque balance. Torque balance is, we know about which point we do, it will be better. Consider any, we don't know n1 or n2. Consider any one of these two. Any one of these two as 1 point. n1 you consider as 1 point. Okay. n1 take it as 1 point. And how much is the distance from here to here? As given, this is a 2. And tan 30 is equal to say x by 2. And x is equal to 2 root. Tan 30 is equal to 1 by root 3. I'm sorry. This is x by 2 and x is equal to 2 by root 3. And 2 by root 3 and 2 by root 3. Total is 4 by root 3. And because of weight, 800 Newton, about normal here I am drawing. And the distance is 2 by root 3. And the clock is in direction is in which direction? Force I am drawing here. 800 Newton in this direction. It will be in this direction. Okay. It is in anti-clockwise direction. 800 into just clockwise direction. Remember, 80 root 3 plus. Let's consider normal. Normal here n2, and the total distance is 4 by root 3. And about this point here, if we consider, it moves in this direction. Minus n2 into 4 by root 3 is equal to 0. We can get n2 is equal to how much? Root 3 gets cancelled. It's equal to 400. n2 is equal to 400. Get the value of n1. n1 also becomes 400. It will be easy up to here. Let's consider what else he asked. He asked tension in the crossbar also. That is very important. Note down. I am deleting it. Okay. Next, to be in equilibrium, any of the parts should be also in equilibrium. Bars, 3 bars are there. I am considering one of the sections. If I consider one of the sections, from here normal will act. What is the normal value? 400 Newton if I am not wrong. And these two, this position, they are in contact. Because of the contact, there will be some reactive force in the opposite direction on it. There will be reaction force. Contacts are there, na? It's a reactive force. And a man weight is acting, this is equal to 800 Newton. At the middle, and there is a tension. Because tension acts in the opposite direction, right? Tension T is acting in this direction. There is no friction, nothing to worry about it. So, what he is asking us to find. So, from here to here is 1 meter. And yeah. From here to here is 2 by root 3. He is asking us to find tension in the cord. Which point we should consider? We don't know. If we consider point T itself, we will not get T, because if at the point P the torque is equal to 0 due to tension, we need to find tension only. If we consider point 400 Newton point, say A, then 400 becomes 0, and we have 800 and R and T. 2 unknowns are there. So better to consider the point C here. If we consider C and R becomes 0, then torque due to R, torque due to 800 also becomes 0. Now only tension is remaining. Because of tension, it is this part. This is tension and this is tension. Because of tension, about this point it goes in this direction. Okay, it is anti-clockwise direction. Minus T and 1. This tension in the perpendicular distance will be 1. As given, T into 1, and right, T into 1, and this is the other force, normal, and it is acting about this point. Position is perpendicular distance, it is equal to 2 by root 3, and the point about this point, it does clockwise direction, plus 400 into 2 by root 3 is equal to 0, and T is equal to 800 by root 3. That is the answer. Okay, let's do the last problem. Normal reaction on the wall. I have so many questions. Note down all the questions, and this is a very, very important question. I will make separate video on it. Try mass of ml is supported by equilibrium against, or if it is in equilibrium, there will be net force is equal to 0, net torque is also equal to 0. I am writing normals n2 and n1. Friction will be in the opposite direction. Friction angle of inclination is theta. Here is an angle theta, and the mass is given m. Mg will act in the downward direction. Normal reaction of the wall on the ladder is okay. Equilibrium against a smooth wall. This is a smooth and friction is 0. And normal reaction on the wall on the ladder. Simple as that. Net force N2 is equal to net force in x direction is equal to 0. Net force in y direction also is equal to 0. Net force x direction, what are the forces? And F is equal to N2, because horizontal force in this direction, in this direction. F is equal to also called mu into N1. Mu into N1 is also equal to N2. What is N1? N1 is equal to next upward force. N1 is equal to mg. Upward force is equal to downward force. And N2 is equal to mu into wait. I did a small mistake here. F is equal to mu into, okay, fine, next direction, right? F is equal to N2, and F is also equal to mu N1, and N2 is equal to mu into mg, right? Next, find normal reaction on the wall of the ladder. Force balance is done. Next, torque balance. Net torque is equal to 0. About which point you will consider? We consider any of the points. I am considering N1 because two frictions are there. I want to eliminate these two. If you want to eliminate, what exactly we need? Okay, not net torque about point P. It is equal to normal. N2 is in the left direction. And what is the perpendicular distance? Here is L. There is an angle theta, and it is L sin theta. L by sin theta, L sin theta. About this point like the same point, it is in the direction, it is anti-clockwise direction, minus N2 L sin theta. And about N1 it is 0, about friction is also equal to 0. Next, downward direction, next mg, what is the value? And here is the distance L by 2. What is the distance? mg. Okay, I am drawing in red ink. Let me erase the other part. The downward direction mg, and from here to here L by 2 cos theta. If you write equilibrium, this is in which direction it goes? In the clockwise direction. Please, mg into L by 2 cos theta. Net force is equal to 0, and L gets cancelled. Minus N2 is equal to mg by 2 sin theta cos theta by sin theta cot theta. N2 is equal to, okay, if you get N2, you can get N1. N1 is equal to N2 is equal to N1 is equal to N2 by N2 mg by 2 cot theta by mu. This is N1. Normal reaction is done. Friction between the force on the ground and the ladder, and net force applied on the ground of the ladder. Net force on the ladder is, get the friction value, mu into N1. That's all, mu into N1. If you do all it, you will get it. Let's do the last problem. Vertical force. See, this is very, very important. Vertical force is applied on the tangentially to the uniform circle rate Fg. So, if we draw free body diagram, gravitational force Fg is acting. The coefficient of static friction between the cylinder at all surfaces, this is 1, two surfaces, everywhere friction is acting. Say this is N2 and friction will act, so force is acting in this direction P. When will be P maximum force? Then all the friction in opposite frictions are opposing it. The friction, say F2 opposite direction, and the F1 is also opposing, because it try to rotate in this direction. F2 makes the body rotate in this direction, F1 also makes the body rotate in the other direction. If all the forces are opposing, then the P will be maximum. Understand? Okay, Fg we got, and there is an upward force normal N1, net force F, say this is F1, net Fx is equal to 0. What are the horizontal forces? N2 F1, N2 is equal to F1. Okay, N2 is equal to F1, and downward force P plus net Fy is equal to 0. P plus F plus F2 minus plus N1 is equal to Fg. I can write N1 as N1 is equal to Fg minus P minus F2 minus F2. This is equation 1. Equation 2, N2 is equal to F1, first expression, upward force P plus F2 plus N1 is equal to Fg, and the downward force. Okay, N1 I wrote Fg minus P minus F2. Okay, now what is the value of F2? F2 is equal to mu into N2. What is F1 value? Mu into N1. Let's simplify that. Mu into N2 is equal to F1. What is the value of F1? Mu into N1. Mu into N1. Right? And F1 is equal to, I am doing small mistakes, consider here, and F2 here, N2 is equal to mu into N1. From here F2 is equal to mu into N2, where N2 is equal to mu N1, mu square into N1 will get F2. F2 is equal to mu square into N1. Let's substitute here. N1 is equal to gravitational force minus P minus mu square into N1. 1 plus mu square into N1 is equal to F gravitational minus P. Okay, so this is the first expression. F2 is equal to mu square into N1. Force balance is done. Third expression. By using next torque balance, net torque is equal to 0. Net torque about any point you can consider. If you want to consider about the center, you can consider about the center, you can consider about or N2, N1, many complications are there. You can consider any of the points. Okay, let's consider the point ground as about this point, about point Q. About this point Q you can consider. If you draw free body diagram again, upward force and direction in this direction, and many forces are acting. It is P mu square N1, and this is N2 N1 F1 mu into N1 Fg gravitational force. If I consider about this point, I can remove three forces at the same time. About the force P is acting, so now consider P into R. this is the point of rotation, the q is a point of rotation. P into the distance is r, force P into r, which direction it moves? In the other direction, clockwise direction, plus. And due to n2 into what is the distance? R, which direction it moves? In the opposite, in the other direction, minus n2 into r. N2 is nothing but mu n1. Okay, and what about mu square n? It is n1. N2 is nothing but, I am writing, simplifying this, n2 is equal to mu n1 minus, it is mu square n1 into the distance from here to here is r, is equal to 0. Net torque is equal to 0 about the point. Simplify it, P into r gets cancelled everywhere, r will be cancelled everywhere, P and P is equal to mu plus mu square into n1. You can replace n1 with, n1 is equal to P by mu plus mu square. Okay, just replace in any one of the equations n1 with this expression mu plus mu square, and if you replace it, you will get the value. I am writing 1 plus mu square into n1 is nothing but P by mu plus mu square is equal to F minus P. This, if you solve this, mu is equal to 1 by 2. If you solve this expression, you will get the value of, find the value of P. That's all the answer. Thank you.